anything will happen to the slab. Yes, again, the positive charge on the plates of capacitor will induce charge, and some spill out due to fringing effect. The electrostatic field will be external to plates also. So because of that, we will get here induced charge. Will be uniform, non-uniform, will be non-uniform. They may test you with these things. We should not show any field in this region. This is very important because the electrostatic field here will be in this direction. It will be there. So now the force will be the interaction force between the positive plate and this induced charge on this charge, positive charge and negative charge here negative positive charge. So the attractive force will be somewhere in this direction. Similarly, F dash. The resultant of this is what? The F, which we are supposed to calculate. Now let's get into, I think, the same equation shall we use, because X length of the slab is there between the plates. X length of slab is there. So directly I'll take this expression, which are going to help us a lot. Huh? This is the expression for capacitance. Then total capacitance of the capacitor. This is now tell me, like, because of force acting, the slab will have a mass. Will have a mass, and what is the volume? And here X, this will be length of the slab is equal to L. So I'll write some condition here. Volume of slab is equal to volume of capacitor. I think is okay. The dimensions, the slab will exactly fill up the gap between the plates of capacitor. There's a meaning of this. Length of the slab is also equal to L. Now, what is my question? I want expression for F. The moment the slab is introduced with X length between the plates, the induced charge, the exerted force and net force will act on the slab. Because of that, it starts accelerating. As it starts accelerating, as X increases, anything will happen to capacitance. Will increase, no? Because when it is fully between the plates, how much capacitance? K times. So as it gradually moves, the capacitance is going to change. Okay, let me differentiate this. DC is equal to, this will be 0 plus equal to 0 epsilon naught L D dx K minus 1, or the change in capacitance equal to F naught L K minus 1 . So this is the change in capacitance. Now look at, come for the capacitor. What quantity of capacitor is constant? Potential remains constant. I think this is something, I'll put it here. PD across capacitor is constant. This is very, very, very important. PD, potential difference across capacitor, is equal to E. Now, if capacitance increases, because as the slab moves, capacitance will increase, then what should happen? The charge should increase. Tell me, who will going to supply this charge? The cell. So therefore, some charge starts moving from here. So that charge, I'll write dq. And the dq charge from here will move, because charge should be conserved. Now after this, dq. So shall we calculate the expression for dq? So the dq is given by dq equal to dc into E. The increment in charge. What is that? The increment in charge. So when the slab moves by a distance, small distance dx, how much of additional charge will flow into the capacitor? Dq. There's the meaning of that one. So this will become epsilon naught L K minus 1 dx E by D, or will have this equation. Very, very, very important. Now dq charge we have brought it. But what was our question? We wanted to get F, no? What to do all further? Okay, I have certain thing. This force, will it does any work? F into dx, it does work, no? Does a thing. Then the battery does work because the positive charge is leaving the positive terminal, it is doing work. Then is there increment in energy of capacitor? Yes, it is. So somehow I should bring the energy relationship between all this. So how to bring that energy relationship now? I think this is already we have done so many problems on work done all. Can you apply this? The energy aspect I discussed very widely, previous problems, work done, action agent, all. So we have to apply the same similar concept here also. I want you to analyze. Now, what is the basic equation? We can write it. Tell me what all happened. The work done by cell, where do it will go? The cell does positive work. So positive work means it supplies energy. The energy supplied by the cell, where all it will go. A part of that energy will be converted into increase in electrostatic potential across capacitor. The remaining will be converted into kinetic energy of slab. I think totally different thing here. Earlier problems, what we did, the work done by cell, half of it will go in capacitor. Remaining off will be converted as heat in the circuit. But what about here? The work done by cell, a part of it will be taken by capacitor. The remaining will be converted into kinetic energy of slab. So therefore, in capacitor circuits, whenever cell does work, whenever cell supplies energy to circuit, half of the work done by cell must be converted into heat, must be generated as heat in the circuit. Will you justify this statement? Answer is no. Maybe you have to put it, but here what happened, the half of the work done is converted into kinetic energy of slab. All of you, are you getting? Sometimes this one, these are the most beautiful parts of the total, like in LC magnetism. We are dealing with more energy aspect here, almost this entire chapter. So the work done by a cell, previous circuits, what all we did, heat generated. Here there won't be heat generated. So what shall we write here? Work done by cell is equal to increment in potential across capacitor plus increment in kinetic energy of the slab. That's what we have to write expression. So how to get the increment in energy across capacitor? Already we know dq. What quantity across capacitor remains constant? Potential difference. So shall we write now? Almost we have everything in front of you. Work done by a cell is equal to increase in potential energy of capacitor plus increase in kinetic energy. Sir, how you can say kinetic energy increases? Say if you go back to laws of motion, if a force acts on a slab, it will accelerate. Due to acceleration, speed will increase. Due to increase in speed, kinetic energy increases. Okay, fine. Now work done by a cell, dW will increment in energy of capacitor duc. What is increase in kinetic energy of slab? Who will increase? This force. So here we are going to write it as F into dx. Here is what I brought the F. Now work done by cell, what to do? E into dq. Do we know dq? That's here. Look at here. We have brought it. Sir, how to bring the increment in internal energy of capacitor? What quantity of capacitor is constant? Cell. What is the potential of a cell in terms of potential difference? C E square by 2. So increment in energy should be equal to capacitance dc E square dc. I'll write it. F into dx. So we want that expression force. Almost, I think now I am very near. What is dq? Value will substitute here. This will be E into books. They are given very complicated way. They wanted expression, not the concept. That's what I'm bringing with through the energy equation. DC value already, I think, on the top, no? F naught L K minus 1 dx by d. This I don't know. The F is unknown thing. Let me just, this F is what unknown. I don't know that. Okay, I'm not bothered about that. So shall we cancel dx? The primary, the first condition, I'll cancel dx. Then after cancelling this, so this will become F naught L E square K minus 1 2d. Okay, this is d. The same quantity, no? Only denominator, this will become 2d plus f. So what is this final equation? The final equation will end up is very important. You have to remember this. Very, 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 very important. So many numericals are there. Some around 20 numericals are there related to mechanics. Not 1, 2. The moment you get force, we know what we do in any chapter. we'll go back to mechanics and we'll explore some numerical. This is what happens here. So what is this F? Force exerted by capacitor on slab. Is it attractive? Yes, attractive in nature. Is it conservative? Yes, conservative. Is it a constant? Look at all the values. Yes, it's a constant. Okay, see the complete description. I think primary thing is this is the which you have to, the whole thing revolves around this, writing this equation. And energy aspect is very important. Means like, sir, is it independent of x? This one. Compare the previous one. For isolated charge capacitor, if you bring a slab, the force was a function of distance. Here it's independent of x equal to L by 3, L by 4, L by 2. The force will be a constant. And it's attractive force. What this capacitor will do, will suck it, will pull that slab into the between the plates. What about the heat generated? Very clearly. Work done, half of the work done by the cell will be there in capacitor, remaining will be converted into kinetic energy of slab. So heat generated in the process will be 0. So no heat is generated. So somewhere we have to write it very, very clearly here. The entire process, no heat will be generated. I'll write it here. Not in capacitor, again related to, okay, I'll write it here. No place, we'll write it here. No heat is generated in circuit. This is, I think, very important condition. So now in a capacitor circuit, a cell, when it supplies energy to capacitor circuit, it must be generated. Need not, maybe you have to put it. That's what I am trying to conclude here. Anybody having doubt, you can clarify it. The derivation is, maybe they ask in board exam, but in advanced exam, nobody will ask you. But we have so many concepts. No. Let me move this slab with a constant speed v. Is it possible for it to move with a constant speed v? No. Some extra agent can do, no. Then what is the expression for current to the circuit? Can we find out? If I move this slab with a constant speed v, what is the expression for current